Before we can dive into the repository module, where all the logic related to save into the database, retrieve from the database, and compare face embeddings will perform. In order to do that, we will need to provide the required dependencies into the repository. For example, the DAOs to access the different tables in the database, or an interpreter which will interpret the machine learning model we are going to use. So in order to do that, we need to create this new module, the repository module, which will provide all the dependencies the repository needs. The first provide function will be the provide TF model, and this requires a extension function, the load file model, because this function will return a mapped byte buffer, which will be required by the interpreted later. So this function is like a skill crane operator, which basically meticulously lifting our model from the storage and placing it in our app's memory. So it uses the asset manager to find the model file, creates a pathway from the file, and finally secures a spot in memory for the model, and then returns it in the form of this mapped byte buffer. So as I mentioned before, this little function has a big job. It's going to dig into our app's assets and fetch out our machine learning model, in this case the MobileNet V2. It's not just a file, it's our app's brain for understanding the images. Okay, we have securely transported our model into the app's memory. What is next? It's not enough to just have the model, we need to interpret it, right? This is the task for provide interpreter. The genius that reads the model is like having an expert who can interpret ancient symbols, but for machine learning in this case. We also want to provide the repository instance in the module. So let's create this interface, FaceAnalyzerRepository, which is a set of promises. One is I will analyze the faces in the image you give me, and two, I will save a new face image. In order to pass the information related to the image we want to save, we need to create this container, which is the data class that represents the person face model, which basically will contain an identifier, the ID, and the name of the person, and also a bitmap which contains the image that we want to save in a form of embedding into the database. Back into the repository interface, we define the last promise function. Now with this we can construct the signature of our repository FaceAnalyzerRepository implementation, which implements naturally from the previous repository we created. And with these two pieces, we can now provide the required instance of the repository. Lastly, in our journey, we encounter the embedding converter, which is a crucial component that translates specific data types into a format suitable for storage and retrieval. Starting from float array to JSON, this function takes an array of floating points number, which represent the unique feature of a face, basically represent the embedding, and converts it into a JSON string. And this is because storing a raw array in a database isn't practical. By converting it to a JSON string, we can make this complex process easier. We do the same but from JSON to float array, which perform the opposite. With this, you can now try to run the app again and see if everything continues working. And that's it. See you next time.